So our robot for Team 25956 Sensory Airflow you may have noticed, can aim at any point on the field and with the press of a button and reset the point that it aims at, also the press of a button. And also customizably sets the power that it shoots at for its flywheel. Today I'll be explaining how that system works right here on this board. So to first understand the math, you have to understand how this graph works. This graph works in a kind of a weird way, as in this is 0, 0 down here. 0, 0 down here is in inches, and this is the corner of the field. The field is also, so 0, 0 is down here. The blue starting goal is right up here, and the red goal is over here. So those are the two goals there that the robot aims for. So it's 0 by 144 inches. These are in inches, so it's 12 feet to cross, 12 feet up. That's how it works. So angle degrees on this field: 0, 90, 180, and negative 180 because it's both of them, and then negative 90 because they both overlap right there. So we're going to set up a point here. Let's say that the robot wants to aim towards the center point right here. This point is 72, 72. So that point there, and let's set a robot point. Our robot point that we're going to be at, for example here, is going to be 80, 80. Just for the sake of example and simplicity. 80, 80. So how we aim our... Oh, and one more thing about the robot. Its direction it's going to be facing is this way. So how do we turn it to face that way? We turn it to face that way by making a right triangle. Like, make a right triangle that way. So you can find out the difference of these right triangles via, like, we get the target x minus the absolute value of the target x. So it's the absolute value of target x minus current x. And the same thing goes for y. So target y minus current y. And that gets these values here, which in this case would be 8 and 8. Using the odometry used on a robot to find these values here in our current positions. So that's how this would work here to get these. So now we need to find this angle here. To get that, we need to do another math equation, which is going to be arctangents. Arctangents work by taking the tangent of the two sides and finding an angle of them. So in this case, it would be 8 over 8. And that would give us an angle here. That would give us x here, which would be that tiny angle there. That would give us our off angle by. So since we know our heading via our IMU, we have our heading, we can use this to find out what heading we need to be facing, and now find out the error degrees by minusing the absolute value of the angle in that. So error degrees will be equaling, in this case, let's say negative 90. So this would give us an error degrees of negative 90. From here, what you need to do is you need to transfer that error degrees into a turn power of sorts. How this works is we take the error degrees and we use a PID of K. We use KP, KI, and KD. These all need to play a part. The P is usually pretty small. I think it's 0.1. The I is 0 because we don't use KI in here, because otherwise it will break. It will run up against the wall, and if it does that, it can continuously break itself. D is like really, really, really low, so it's that, I think. It's that in the program. So we set this for these, and we use some multipliers and some adders together, all to get a turn power degrees. A turn power value. This will be applied to our motors during the automated state to slowly give it a power and let it start turning. this equation is ran over and over and over again until its position starts getting closer and closer to there. And when it eventually hits there, it will stop doing it, but it will keep correcting when it's done. That is how that system works. That's the complicated system on our thing, and that's how it really is working on the inside. It's a lot of mathematical equations. On to our next system. I'm going to erase the clutter out of this now for simplicity because we're going to need some space for this one. So now we're going to set a new point just for simplicity. It's going to be 75, 76, which means that this is going to be 4 and 3 right here. This is going to be for simplicity because what we're going to be using to determine our power for our motors is we need to first find the distance to that said point. This would be obviously using the Pythagorean theorem. The Pythagorean theorem is, a squared plus b squared equals c squared. In Android Studios, though, it is known as the hypot equation. Hypotenuse or something. So that would give us 5. And that would give us our distance from this point to that point. So now that we have our distance, what we need to do now is we need to get another graph. We need to run it through an equation to turn that amount of distance into a motor power. What we used for this is we set our motor speed to something in our old teleop, we moved it back until it worked, and then we recorded the distance to the hoop, and we kept recording distances and distances and distances. We recorded, I think, about 6 of them, and eventually we got ourselves an equation. This equation does not look like linear, because it isn't linear. Because since we use 2 motors to run our thing, it's not linear. But you can find your own equation if you just run enough points of stuff. The thing is, this is not linear. It took a good bit of stuff to do. We had to run through a whole bunch of different equations to find the line of best fit. This ended up being power regression. There were a couple close ones, like logarithmic and stuff, but their equations were not simple. The power regression thing is y equals a value, we're going to say that this is w, a value plus x to another value. That's how it is. So now that we have this, I think it was y equals 406 point something something, so I would say 68, plus x to the 0.6874 power. And that gave us this. X would be our distance, and it would output us a power for our thing. Now that we have a power for our thing, though, it will give us the correct power for our distance. With both these working together in tangent, this will be able to give us a correct power for the distance away from the point that we needed. So that is how all of this stuff works in tangent to create a very good teleop for our robot and a very nice experience for our drivers.